Hello and welcome to my presentation on multi-level action design research, design science research approach to creating public value in a smart city. My name is Stephen Dawe, and a smart city is a set of business processes coupled with information systems that use the data generated to make better decisions based on the data that is available. And I'd like to add here that the information systems and what makes the city smart is the amount of data that's becoming available enables us to make smarter and smarter decisions. However, this also increases complexity, and a smart city covers many, many disciplines, and not one discipline is able to say, we can build a smart city. We need public administration, we need information systems, we need computer science, urban technology, all kind of different things. So that's why the complexity of smart city is there. Smart city requirements and the requirements of the information systems and business processes need a systems thinking approach. And the reason for this approach is we need to handle the myriad of systems that work within a city and work within a city government to make each one of those systems smart. And then we need to integrate the data that comes and all the data flows that come from all of those systems so that the right data can be given to the right decision makers at the right time. The complexity of a city is so big that no one person within a city can fully understand how everything works across all departments. That data has to be abstracted, and as you move up the different layers of management, and therefore these many subsystems are required to give line managers, department managers, division managers the data that they need to make decisions. The environment of a city is also constantly changing, which makes it very reactive. We have many, many information technology systems out there that are capable of measuring various parts of the city, the number of cars on the road, the gases in the air, the number of people on the streets, the directions they're traveling in, the weather, the road conditions, all these different things. However, our decisions are based on are reactive to those, and therefore this lack of predictive nature in a constantly changing environment um, means that our decisions are reactive. That the decisions within city government are reactive, and we need to get to a point where we're actually using the information technology in our systems and those integrations to start making predictive decisions to enable the city to flow faster. So we're making decisions before a reaction is required. There are many practical concerns when building a smart city. And from a research perspective, we aim to fill some certain gaps where we need to help practitioners in cities of all sizes build a smart city system. How do you begin to build a smart city system? How do you think about the business processes, the strategy? And how do you put that together so smart city isn't a goal in itself, but becomes part of everybody's goals and actually is the tool that is used to help people meet their goals? Ultimately, smart city needs to provide value. And in our case, we have chosen Mark Moore's public value framework as our method of providing value. Public value is a fairly nebulous concept, and in Moore's work, he actually says the city needs to define what public value actually means. Or actually doesn't say city, everybody needs to say what. And the stakeholders define what valuable value means to them. This encourages an entrepreneurial approach to strategic choices because we can look at value in many different ways. It's not just the values of dollars and cents, it's also the value of services, it's the value to citizens in time saving or not having solid waste on the streets, or that the sewage is pumped properly and is cleaned properly and disposed of properly. The energy usage is managed correctly across the city. that city governance exists to protect people's data, the transportation systems within the city, whether it's for cars, trains, buses, or whatever, are working efficiently, and so on and so forth. Smart City project is a set of business processes, information systems, and measurements and decisions based on those on the data generated. Action design research allows for the generation of these new processes based on the project management plans and the strategic plans of the city. Design science research creates the supporting information systems artifacts that help automate and record the required knowledge uh, for reporting and decision making. This also includes the knowledge that is kept when creating these processes. A city is constantly evolving, its environment is constantly changing. Therefore, the processes, the protocols, the information systems must also evolve with the city. As these iterations of design go forward, the knowledge gained in the last design process can feed and feed the next iteration of the design process as the city moves to meet its goals. This constructive approach allows city stakeholders to give meaning to the variables that they are interested in and allows for individuals to decide how to interact with their smart city government and see how the smart city government can help them with their real problems. This takes away the significance of any relationship between the variables. The way action design research and design science research looks at this is the stakeholder is the person who is interested in the results of that system. Did that system help them with their problem? It's a very simple yes no question, but that's how value is derived from the system. And each individual who uses the system is going to derive value slightly differently. But unfortunately, having no unified theory of city means that we're going to have to build these artifacts and design these systems and then test them and actually use them to see if they add value and measure their effect on the city as a whole. If their effect is positive, then we can keep the system. If their effect is negative, then we need to change the system or even do away with the system. We can also learn from failure. ADR and DSR provide a framework with which we can learn by doing. Design is a creative process, and experience and the reuse of previous artifact design knowledge enables the smart city to continuously improve. And this leads us uh, to how we need to think about city government or any government. But basically, when we think about government and we think about governmental budgets in particular, the government must be able to produce the same outputs as before at less cost. Budgets never go up. And a smart city government must be able to produce more outputs than is currently possible at the same cost. Basically, what that means, and when we've surveyed citizens, citizens expect a city government to act just like a business. As businesses add services and citizens use those services, they expect their government to add the same services and to interact and to be able to interact with the government in the same way they do with business. So this leads us to two theories that we can use for smart city. The theory of economic transaction cost provides a lens which we can look at our artifacts and say how are we reducing the cost of a transaction? How are we reducing the cost of an interaction with the city government? And of course, the goal would be to reduce those costs to zero. Of course, that's not practically possible, but that would be the ultimate goal of this theory. On the flip side of that, we have stakeholder theory, which governs the relationship between the government and its citizens in their demand for services. Generally, stakeholders in government demand services regardless of cost. So now, stakeholder theory allows us to say This is the minimum level of service that the city is going to provide, regardless of the cost of providing that service. Unfortunately, stakeholder theory also allows there will be political decisions made, and decisions where finance is not the primary driver of the project. And but for each individual project, regardless of how it was created or which stakeholders created it, we must look for a project to be considered smart. What are the outcomes of the project, and are we achieving those outcomes? Are we open, and do we provide transparency? Are we allowing citizens to see how the operations of the city take place? Are we saving the data? Are we protecting the data? Do the EIS artifacts bring a consistency and quality to the interactions that the citizens or city employees have with the city? And ultimately, with economic transaction theory, are we efficient? Are we driving cost and driving the cost of a transaction downwards? A smart city is concerned with all of these different things, four different things. As I've been working with a city over the last several years, we've developed the artifacts listed in this table. Each of these artifacts fulfilled a business need, but also filled a gap in the overall smart city strategy. In this particular presentation, we're going to talk about the authorization model. That being the first part that we looked at. As we looked at public value and we looked at how we were going to create it, everything else then kind of follows from that and supports that goal. So each one of these different models is a business process or set of processes or protocols that allows the city to operate digitally, that allows the city to provide the systems that are in place, and allows the city to not build boutique projects where every project is integrated and the data flows are integrated into one overall system. In Moore's strategic triangle for public value, he says that legitimacy and support and operational capacity are required for public value to be created. So, support for a project comes from a demand for service. Citizens have demand for service, politicians have a demand for service. And then on the governmental side, we have a financial feasibility. Is this service cost effective? Is this service affordable? Is this service financially feasible? Then we can ask the questions, is this service technically feasible? Do we have the skills to offer this service? How can we offer this service if we do not have the skills? How do we obtain the skills if we're going to offer this service? And then, particularly here in the south of the United States, is the service going to function equitably for all members of society? That's a big thing for the politicians in the city that we're offering. So digital equity is something that must be built into every single project. Of course, we have our theories there, and you see that the structuration theory was added to the list. And structuration theory basically means that we must learn from each individual process. So in our process of becoming a learning organization, structuration theory meets the goal of learning from the project failures, project successes, and all the actions taken within that paradigm. At the bottom of the model, you can see we have our actual design model here, where the authorization will then feed the project into the design model, and the outputs will be decided. The business processes and operational process will be there. Public value should be recognized, going back to the stakeholders. And there's then the possibility of more demand for services via a similar system or a subsequent system, or even additional features to this particular system. As we become a learning value, you can see that there are lots of constraints. We need to meet public value in terms of trust, legitimacy, fairness, equity, service quality, accessibility of services. But we have to have the operational capabilities to provide that. Do we have the legal power? Do we have the people, the skills, the finances? And ultimately, even in the authorization environment, is it legal to do what we're doing? Is it politically tenable? Does the city have the resources? Does the community at large support this? And and then we have a generalized model for the actual design process. So this process is in two layers. The first layer being the build, implement, and evaluate at the city level. This is the multi-level. Um, each ADR DSR process at the city level is looking at the integrated set of data and the holistic data from all the city systems as a whole. Public value here is optimized for the city as a whole, and anything that exists at this level can be used by any new single project. That's part of the goal there. We're trying to create a whole system that is fully integrated, and then at the single ADR level, we can build, implement, and evaluate an ADR project. We have individual project management, and we have our DSR, our information systems projects. If new databases need to be created, if new system artifacts need to be built, new programs, if new things need to be integrated together, new sensors need to be added in from it. How is that going to fit with the technology that already exists in the city? How is that going to fit with? How is that data going to be ingested into the business processes and used? This is all evaluated at each individual level. The knowledge is recorded from the design process, the knowledge is recorded from the build process, and of course the knowledge, and then from the use of the system. The project finally is delivered, and the project is then evaluated as part of the holistic city and optimized to optimize the results of the whole rather than optimizing the results of the individual system. And as you can see here, this then meets with the authorization process and the stakeholder demand. And of course, because this is used as a research model, the research knowledge for designed artifacts and implementation and use are recorded so they can be reported as part of a larger research project. And the we use this ex post framework because we want to evaluate real artifacts. A smart city is a city. We can create test beds and we can create demos in classrooms and we can create smaller versions of the DSR artifacts. But however, we need to put those into use and actually evaluate their use and evaluate how they're used for decision making to justify their creation and justify the continued investment in that project year on year, year on year. It's the budgeting portion of the smart city and the longitudinal survivability of a project must mean that data is continuously used. If those systems are no longer used or they become replaced, then we need to evaluate all the projects and we need to evaluate it at the city level to say what happens when we take this project out. How does that affect the other systems around it? Does a system exist to feed other subsystems? Does it not do anything? That by answering those questions, we can decide how to keep the project mix alive and ensure that the city is not paying for projects that are no longer used. And this has been a problem over time. When we were replacing legacy systems, we found many legacy systems that were not used and had been paid for years and years and years. Ultimately, we're looking at the behavior of each artifact to ensure that we get the greatest utility for the smart city as a whole, and make sure that everything is done utilizing the economic theory of transaction cost. Are we being efficient? And are we providing what the stakeholders are asking for? And by using those two theories, we can make sure that the smart city is responsive to the needs of the community and is efficient and fiscally responsible and sustainable. And this way, once we add the structuration theory in there, I said once we can also make sure that learning takes place, that the organization learns from the information through the design process, and that knowledge can be used and reused and passed into the next iterations and into new artifacts as they're required and built throughout the city. Thank you very much for listening to this presentation, and if you have any questions, please email me.